So good evening everyone, and in today's session we'll discuss about the understanding of inductor and capacitor. So we'll discuss about inductor and capacitor. Okay, so it's again very simple and it's a fundamental lecture for power electronics. So this session is in this session we'll start the basics of power electronics. Okay, and I hope you'll enjoy this session. इस session में हम लोग पूरा inductor और capacitors की जो conditions हैं उनको हम समझेंगे, and let's see. I hope you will enjoy. This is my introduction, and I'll teach almost each and every subject. So this time power electronics is on the way. Okay, so we'll start power electronics in this in this session, and upcoming session भी मेरे power electronics पे रहेंगे कुछ, and after that we'll start with machines. Okay, if you have not subscribed our channel, please subscribe it and make sure that you press the bell icon and like this session. If you press the bell icon, you'll get the notifications, so please do it. Okay, let's move to the next slide. And yes, so on 18th of December there is one mega workshop is going on, and that workshop is conducted by Rakesh Talreja sir, and you can join this session. आप इसमें आइए और सर के साथ जो इनके जो टिप्स हैं और जो इम्पोर्टेंट पॉइंट्स हैं फॉर गेट 2024 उसके लिए आप ज्वाइन कीजिए सर को एंड जानकारी लीजिए, इनके एक्सपीरियंस का फायदा उठाइए. गेट PYQ सीरीज हमारी चल रही है दोस्तों, ये स्टार्ट होने वाली है. मैं आपको बता देता हूँ, फ्रॉम 18th ऑफ दिसंबर PYQ हम सोल्व करेंगे, एंड दोज PYQ विल स्टार्ट फ्रॉम 2018 टू 2022, मतलब लास्ट 5 ईयर्स के आपको PYQ हम लोग सोल्व करवाएंगे. सो अगेन इट्स वेरी इंटरेस्टिंग सीरीज. आपको सारे PYQ मिल जाएंगे, खासकर लास्ट 5 ईयर्स के ऑलमोस्ट हर क्वेश्चन को हम कंप्लीट करेंगे इसमें. सो यू कैन ज्वाइन दिस सीरीज ऑल्सो, इट इज़ वेरी हेल्पफुल फॉर एवरीवन. सो आप इस सीरीज को भी ज्वाइन कर सकते हो स्टार्टिंग फ्रॉम 18th ऑफ दिसंबर. ओके, देयर इज वन मोर पॉइंट दैट आई वांट टू टेल यू इज, अभी जो टाइम है वो टेस्ट सीरीज का टाइम है. चाहे आपने कितने भी सब्जेक्ट प्रिपेयर किए हो, वेदर इट इज 7, 6, 8 व्हाटएवर, ओके, जो भी आपने जितने भी सब्जेक्ट तैयार कर रखे हैं, आप उन सब्जेक्ट्स के टेस्ट देने स्टार्ट कीजिए. अब टेस्ट कहां से दें, उसके लिए आप बायजूस एग्जाम प्रेप से टेस्ट सीरीज ज्वाइन कर सकते हो. उसमें फुल लेंथ मॉक टेस्ट भी मिलेंगे, सब्जेक्ट टेस्ट भी मिलेंगे. उसका जो लिंक है वो डिस्क्रिप्शन में दे रखा है टेस्ट सीरीज के लिए. सो यू कैन ज्वाइन टेस्ट सीरीज फ्रॉम बायजूस एग्जाम प्रेप और उसका आप फायदा लीजिए. उस टेस्ट सीरीज में अगर आप देखते हैं तो 60+ टेस्ट आपको मिल जाएंगे. ओके, एंड डिटेल्ड मॉक टेस्ट भी आपको मिलेंगे. उसका जो एनालिसिस है वो भी आपको मिलेगा. जब आप टेस्ट परफॉर्म करोगे तो कितना टाइम लगा, आपने कितना मिस्टेक्स किया, एवरीथिंग इज देयर. और बिल्कुल गेट ओरिएंटेड है, मतलब वर्चुअल साइंटिफिक कैलकुलेटर भी आपको उसमें मिलेगा. एंड बाकी मतलब काफ़ी इसमें सारे फायदे हैं, और जो क्वेश्चंस हैं वो करीबन 4000+ क्वेश्चंस आपको इसमें मिल जाएंगे. ठीक है, तो मेक श्योर कि आप टेस्ट सीरीज जरूर ज्वाइन करें. एक मॉक टेस्ट अभी हम कंडक्ट कर रहे हैं, और ये मॉक टेस्ट जो है वो हमारा 13th ऑफ दिसंबर से 20 ऑफ दिसंबर तक आप इसको रजिस्टर कर सकते हो, और ये टेस्ट आप इसको दे सकते हो दोस्तों. तो मेक श्योर कि आप गेट 2023 के लिए तैयारी कर रहे हो तो आप इसके लिए रजिस्टर करें और मॉक टेस्ट दीजिए. आप अपनी तैयारी चेक कीजिए कि किस तरह की आपकी तैयारी है. ओके, सो लेट्स स्टार्ट द सेशन गाइज. आई होप एवरीवन इज फाइन देयर, एंड let's start this session. So first of all, let's discuss with inductor. Let's start with the inductor. How inductor behaves, let's try to understand that. Everyone know that in inductor, if let's say this is VLT and this is inductor with inductance L, and if I take current IT, if I take this current IT, then I can write that VLT is equal to L dit by dt. So if anyone provide you the wave shape of current, you can take the derivative of that wave shape, multiply with L, you'll get the wave shape of voltage across the inductor. It's very simple. Okay, so to draw the wave shape for VLT, if current wave shape is given to you, you can easily draw the wave shape for VLT. You can invert this relation. You can invert this relation. Now if you invert this relation, that dt will be you can take this dt on the right side, so it will become, let me take this dt on the right side, so it will become L dit is equal to VLT dt. Now take this L again on the right side. So you can say that dit is equal to 1 by L VLT dt. Everyone know that. Now you can take integration on both sides. If you take integration on both sides, this integration is with respect to time and this integration is with respect to current. So let's say time is changing from 0 to t. At t equal to 0, the current is I0, and at t equal to t, the current is IT. So if you try to solve this, it will become IT minus I0. It will become IT minus I0 is equal to 1 by L 0 to t VLT dt. Now take this I0 on the right side and you can say that this is the equation that you will get. So you can invert this differentiation relation into integration relation. Okay, if current is given to you, if current wave shape is provided to you, you can plot the wave shape for VLT, and if the wave shape of VLT is provided to you, then you can plot the wave shape for current. Okay, so it's easy peasy. You can calculate the, you can plot the wave shape for current and voltage for both. Okay, if one is provided, then other you can easily calculate using differentiation or integration. But there are some important points which are hidden in these two lines. What are those points? First point that you need to remember is, whenever you have the maxima of the current, let's say some current is flowing in the inductor and the current has the maxima. If current has the maxima or the minima, local maxima or local minima, whatever, if current has maxima or minima point, at that point VLT will be 0. Okay, or converse, in a converse way, you can say that if VLT is 0 at some instant, let's say VLT is 0, at that instant current will be either maximum or minimum. Okay, if VLT is 0, inductor is a passive element. Inductor is a passive element. Let me tell you again. I told you that if current has the maxima or minima, at that instant VLT will be 0 according to the maxima condition. Conversely, you can say that if VLT is 0 at some instant, let's say there is some instant at which voltage across the inductor is 0, at that instant you can say that IT will have either maxima or minima, or it may be constant. It may be constant. If it is constant, then again VLT will be 0. Okay, I hope you understood it. So let me write the first point. If VLT is 0, if VLT is 0, if the voltage across inductor is 0, then you can say that IT has either maxima or minima, or IT is constant. IT is constant. Either IT is constant, maxima or minima. Okay, according to this relation you can say. Now what about this relation? According to this relation you can say that, using this relation you can say that if current is periodic, then the average voltage across inductor will be 0. If current is periodic, then the average voltage across inductor is 0. Now you will ask me why. Let me tell you guys. Let's say current is periodic. It means if IT is periodic, it means I0 must be equal to IT. Let's say the period is capital T. So you can say that I0 must be equal to IT because it's repeating, it's periodic. Now in this expression, on the both side, if you put small t equal to capital T, put t equal to capital T. In this expression, if you put t equal to capital T, then this equation will become I capital T is equal to I0 plus 1 by L integration 0 to capital T VLT dt, right? Okay, now we know that current is periodic, so this will be cancelled. From here I can say that integration 0 to t VLT dt is 0. It means area under one period become equal to 0. Take this L on the left side and it will again become 0. So you can say that the area under one period of inductor voltage is 0. If current is periodic, if current through the inductor is periodic, then you can say that the voltage across the inductor will have zero average value. Average means DC component. It means the voltage across the inductor does not have any DC component if current through the inductor is periodic, and vice versa. So let me write it. If IT means this current is periodic, if IT is periodic, then VLT average will be zero. Then VLT average will be zero, and vice versa. And vice versa. Just remember this point. These 2 points are very important. First point is, if VLT is zero, if voltage across inductor is zero, then the current have either maxima, minima or constant. If IT is periodic, then VLT average will be zero. Average voltage across inductor will be zero. And vice versa. Vice versa means if average voltage across inductor is zero, it means the current will be periodic. Okay. Just remember these 2 points in inductor. It will help you at many situations. Okay. Sir, source voltage periodic है तो current through inductor भी periodic होगा RL circuit में? Yes. अगर source voltage periodic है तो RL circuit में current भी periodic होगा under steady state. Okay. Let me tell you why. Let's say I have this RL circuit. ये मेरे पास RL circuit है, and let's assume that this voltage is periodic. This is the source voltage. It is periodic. Let's say it's a triangular shape. Let's say the voltage is of triangular shape. Let's assume that the voltage is triangular. Now, in triangular wave, let's say this is 10, this is minus 10. This is my VST. ये मेरे पास RL load है, and across RL load I connected a source, and the source is triangular, it's periodic. Then this current will always be periodic. Under steady state, this current will be periodic. Why? Why this current is periodic? The reason is, according to Fourier, you can expand this. You can say that VST contain sinusoidal term. It contain odd harmonic sine terms. So you can say that it can be represented as summation Bn sine of n omega naught t, n from 1 to infinity, and n is odd. It means it contains odd harmonic sine terms because it has odd half-wave symmetry also. Now if I expand this, then you can say that B1 sine of omega naught t, this is the fundamental term, B3 sine of 3 omega naught t plus higher harmonics. It means the voltage has these terms, fundamental, third, fifth, seventh, these type of harmonics are there in the voltage. Now every harmonic will provide its current. Let's say the fundamental component. Due to the fundamental component, the current will be, now the current will be B1 sine of omega t divided by R plus j omega naught L. The current due to third harmonic will be B3 sine of 3 omega naught t divided by R plus j 3 omega naught L. Current due to fifth harmonic will be B5 sine of 5 omega naught t divided by R plus j 5 omega naught L. You can see that. This current itself is periodic current. This individually it's periodic. So every component is periodic. Fundamental component is periodic. Third harmonic component is periodic. Fifth harmonic component is periodic. Now you can calculate the overall period of the current. Because let's say this period is T1, this period is T2, this period is T3, let's say. So what you can do is take the LCM of the numerator and HCF of the denominator. So you can say that the overall current will also be periodic, because these components individually periodic. And we can also show that whatever period we have here, let's say the period is T1, here the period is T2, here the period is T3, let's say. Obviously we know that fundamental frequency is omega naught. Here the fundamental frequency is 3 omega naught. So you can say that the period of this component will be, whatever period we have here, let's say T1, the period here will be T1 by 3. Here the period will be T1 by 5. let me tell you guys. Let's say the period of fundamental is T. Period of the fundamental component is T. Wait a minute. Okay, let's say the period of the fundamental component is T. Now, the period of this third harmonic component will be T by 3 because the frequency is 3 omega naught. And here the fundamental period will be T by 5. Now, what you need to do is you take LCM of numerator and HCF of denominator. You will get the overall period. The overall period will also be T. You can see that. Whatever the period of this wave has, the same period will be for the current. So you can say that whenever the source is periodic, under steady state, the current in RL circuit will also be periodic, but not in L. Not in L. Whenever there is only pure inductor, then you have to think about it. Whenever the load is pure inductor, let's say the load is pure inductor. Let's take pure inductive load. Okay. If I take pure inductive load, then what about the current IT? Look at the voltage VST, source voltage. The source voltage is voltage across the inductor. The source voltage itself will be the voltage across the inductor. And now, if the voltage across the inductor has zero average value, it means the current will be periodic. Now, you have to check the average value of the source voltage. If the average value of the source voltage is 0, then you can say that the current will be periodic. Otherwise, the current will not be periodic. Okay? I hope you understood it. फिर तो average voltage resistor के across आ जाएगा. No. Let's say this is periodic source voltage, and if you take RL load, I told you that the current will also be periodic. Okay, in RL load, whenever a load is RL, if the source voltage is periodic, then the source current will also be this current will also be periodic in RL load. But this is not true in L case. In L, only L is there. If only L is there, then you can't say that. Then you have to check whether the source voltage has zero average value or not. If the source has zero average value, then you can say that this current will be periodic. Otherwise, this current will not be periodic. Let's say the average value is positive here, then the current will be rising. If average voltage is negative here, then the current will be falling. Let me take an example. Let me take a question. But in RL load, you don't need to worry about it. You don't need to worry about anything. We can say that whatever the source voltage is, whether the average is 0 or not, doesn't matter. Okay? If the source voltage is periodic, the current will also be periodic. Now, if the current is periodic, then you can say that the average voltage across inductor is 0. Average voltage across inductor is 0. It means whatever average this source has, the same average will appear across R. The same average, because average across inductor is 0. Average, because the current is periodic. In RL load, remember this point. In RL load, if source voltage is periodic, current will always be periodic. Okay, you don't need to think about it, anything. But in L, you can't say that. RL, whatever type of VS is, if it is periodic, whether it has average value or it doesn't have average value, doesn't matter. If VS is periodic and if the load is RL, if R is there, if load is RL, then you can say that the current will always be periodic. Okay? But in L, you can't say it. Okay? In L, you have to check the average value of the source voltage. Is it fine, guys? Can I proceed? Shivam, can I proceed? I hope you understood it. So I told you that you need to remember these points. If VLT is 0, then the current either has maxima, minima or constant. If IT is periodic, then the average voltage across inductor will always be 0. Now, in this case, since IT is periodic, we know that the voltage across inductor, average voltage across inductor will be 0. So if the source has some average value, that average value will appear across R only. Let's take an example. Let's take an RL load. Let's take an RL load. Okay? And here I have the source. Here I have the source. And the source wave shape is shown like this. VST is shown like this. Okay, 0, 1, 2, 3, 4, and this side is 10 volt. Okay, this is my VST. Let's say R is of 10 ohm and L is 0.5 Henry. Okay, what I need to do is I need to calculate IT average. find IT average. What is the average value of the current? Find IT average. How to calculate the average value of the current? Now, let me tell you guys, since the VST is periodic and the load is RL, I told you whenever the load contains the resistive part, if supply voltage is periodic, current has to be periodic. It has to be periodic all the time. Since the load contains R part, since the load has R part, resistive part, so you can say that this current will be periodic. Since the voltage is periodic. If the voltage source is periodic under steady state, you can say that the current will also be periodic. If the current is periodic, you can say that the average voltage across inductor will be VLT average will be equal to 0. Because we know that if current through the inductor is periodic, then the average voltage across inductor is 0. It means whatever the source has the average voltage, entire source average voltage will appear across this resistor. Now, what is the average value of the source voltage? The average value can be calculated using this wave. What is the average value of this wave? You can calculate area under one period divided by time period. So area under one period is 1 by 2 into peak value is 10 and this length is 2. This is the area under one period divided by the time period 2. This will be cancelled. So you can say that the 5 volt is the average value. 5 volt is the average value of the source. So you can say that whatever the source has the average voltage, that entire average will appear across R only. So you can say that 10 into IT average, this is the voltage across 10 into IT average, 10 into average current, that will be the average voltage which will appear across resistor, and that must be equal to average value of the source voltage 5, because the average voltage across inductor will be 0. So from here you can calculate IT average. So IT average will be equal to half ampere. Is it fine, guys? Have you understood it? Tell me, guys. Under steady state means, yes, everything is under steady state. Because if you are thinking about transient, let's say you are closing the switch, then initially you will not see the sinusoidal nature of the current. There will be some exponential term will also be there. I mean, you can't say that the current will be periodic. Okay. Under steady state, this will happen. Okay. So I told you how to calculate the average current in this situation. Okay, so it's very simple and you can easily solve it. Okay, hello everyone. Badam, Amrendra Reddy. Hello guys. Good evening everyone. So I told you what will happen in case of RL load and if the source is like this. Let's say the load is pure inductor. No, it doesn't has the R part. Let's say the load is pure inductive. Let's take an example like this. Let's say the load is pure inductive and the source voltage is this. First, let's say this is the source voltage. Now, what is the average value of the source voltage? Can you tell me? This side is 10 and this side is minus 10. You know, tell me the average value of the source voltage. Oh, this is VT. What is the average value of the source voltage? VST you call. You can see that the average value of the source voltage is 0. The area under one period, the time period is 4 here. If the time period is 4, then the area under one period, you can check that the positive area is equal to the negative area. It means the average value of this VST is 0. Area under one period is 0. So the average VST is 0. Across this inductor, you can say that the average voltage is 0. It means the current will be periodic. It will be periodic. You can say that the current is periodic. That's for sure. Even you can calculate the wave shape of current. How to calculate the wave shape of current? Just by using this integration expression. You know how to apply this integration formula. Otherwise, you can't solve it. Okay. You can't draw the wave shape of the current. It will be difficult for you. Okay. But I don't want to draw the wave shape first. Just I want to tell you whether the current will be periodic or not. Since the average value is 0 here, that's why the current will be periodic. Now, let's say the source voltage is like this. Let's say the source voltage is like this. Now you can see that average value is not 0. Okay, let's say this is 10 volt. This is my VST. Now, under this situation, since the average value voltage across inductor the average voltage across inductor is not 0. It has some average value. If it has some average value, and since the average value is positive, so you can say that the current will not be periodic now. It doesn't contain R part. So you can say that the current will not be periodic and current will keep rising. So in this situation, if voltage is periodic, you can't say that the current is periodic. Okay, I hope you understood it. Okay. Okay, Amrendra ready. Thank you. So I told you what will happen in this situation. Okay, you just remember what is the meaning of this line. Okay, I hope you understood it. Now let's understand the transient part, because this is the steady state part. I told you about the steady state. Everything is under steady state. This statement is also applicable for steady state. Now what about what will happen under transient situation? Under transient situation, even if you have the sinusoidal voltage, even if you have this periodic voltage here, the current will not be periodic. If you close the switch at, let's say at t equal to 0, if you close the switch, the current will not be periodic, and you should know how to write the current equation. How to write the current equation. You should know that, because this current equation is useful in calculating, you can say, many terms. I mean, the current equation is useful in many calculations, like whenever you study about the phase, you study phase control rectifier. In that phase control rectifier, you need to calculate for what firing angle the conduction is just continuous or discontinuous. Okay, so for that you need to calculate this current equation. So you should know how to write the current equation. Now let me tell you how to write the current equation, and let me tell you some more points about inductor. So in this case, I close the switch at t equal to 0 and the load is RL. Now obviously what will happen is, as soon as you close the switch, before closing it, the switch was open obviously, and the current was 0. There was no current in the inductor. Previously there was no current in the inductor. So at t equal to 0, what you did is you close the switch. If you close the switch, obviously this current will start from 0 value itself, because the inductor will say that since my previous current was 0, so obviously I will start from 0 only, because I cannot change current abruptly. You know inductor situation, inductor condition. If you have studied transient, then you must know that inductor will say that since my previous current was 0, so I will start the current from 0 itself. So you can say that this current IT, as soon as you close the switch, this current IT will have two parts. One is IT steady state and one is IT transient. One is IT transient. It has two parts. One is steady state part and another one is transient part. Now how to calculate the steady state part? Steady state part is very easy. Using network theory, you can calculate the steady state part. And the steady state part will be Vm sine of omega t divided by R plus j omega L. Because under steady state, this inductor will behave like reactance j omega L. So the total impedance of this path is R plus j omega L. So you can calculate this current. This is called IT steady state. This is IT steady state. Now you can write this IT steady state as IT steady state will be equal to Vm by Z sine of omega t minus theta z. This will be my steady state current. This is my steady state current. Now how to write the entire equation? We know that the switch is closing at t equal to 0. What is the value at t equal to 0 for this steady state current? The steady state at t equal to 0, the steady state current has the value Vm by Z sine theta z with negative sign. If you put t equal to 0 in this equation, then you get minus Vm by Z sine theta z. This is the current value. This is the current amplitude at t equal to 0. But the current cannot start from this value. Current has to start from 0 value. If you try to plot this steady state current, the steady state current will look like this. It will start from some negative value. It will start from this negative value. But we know that the current cannot start from the negative value. Previously the current was 0, so current has to start from 0. How to make it 0 at omega t equal to 0? How to make it 0? There is one way. Whatever the value of this current is at t equal to 0, the negative value of that I have to add. We know that the value of this current at t equal to 0 is this. Now we have to make it 0. How to make it 0? whatever the value this current has at t equal to 0, just add negative of that, opposite of that. So you can say that there will be one more current to make it 0, at omega t equal to 0, to make this current 0, what I need to have is one more current, Vm by Z sine of omega t minus theta Z. This is the steady state current. Now at omega t equal to 0, this is negative current. To make it 0, what I need to do is, I need to add opposite to this value. At omega t equal to 0, it's negative, and opposite to that is positive. So I have to add Vm by Z sine theta Z. I have to add this current at omega t equal to 0. I have to add this current, but this current should decay exponentially. This current, because it's a transient part, so it has to decay, minus R by omega L omega t. Okay, R by LT. So I divide it with omega, multiply with omega. So this is the transient current. This is the transient current, and this is the steady state current. So this current has to flow. Now you can see that if I consider the transient part, then there will be one exponential term which will flow. There will be one more exponential term. Along with the steady state part, we have one exponential term. And this is important, guys. This is important, okay? So I told you about the AC transient, how the current will look like in AC transient, and you can see that this current is not periodic. This current is not periodic due to this exponential term, okay? Now I want to plot this current, and I want to plot the wave shape of this supply voltage, and along with that I want to plot this current. Now let me plot this, guys. So I need some blank space, okay? So this is the blank space. Now you can see that I have the circuit like this, R and L, and I have the switch here. Okay, this was the circuit, guys. Vm sin omega t. This was the circuit, and the switch is closed at t equal to 0. This is R, this is L. The switch is closed at t equal to 0. Now, we know that the steady state current is this. This was the steady state current. Let me do it properly. So this was the steady state current, okay? And there is one more current, transient current. To make it 0, this value is negative. To make it 0, I have to add the opposite to this value. This value was minus Vm by Z sine theta Z. To make it 0, I have to add the positive value, Vm by Z sine theta Z, and this value will decay like this. So if I add both of them, then the resultant current will look like this. The resultant current will look like this. Is it fine? Is it fine? I hope you understood it. Okay. Wait a minute. Now you can see that the 0 will appear here, because at this instant the exponential term is positive and the sinusoidal term is negative. If you add them, it will become 0, and then it will go like this. Somewhere again at this point it will become 0, and then eventually it will approach the steady state current. So this will be the wave shape of current. You can see that it will start from 0. It will start from 0, okay? And again it will become 0 after pi. After pi, you can see that if it is 0, if this point is 0, this point will be greater than pi. So it will be 0 after pi. You can see that. So there are two current which will flow. One is steady state component, and another one is the transient component. I hope you understood it, okay? Now what I want to tell you is, let me draw the voltage wave shape and the current wave shape. The voltage wave shape is pure sine wave. So if I draw the voltage wave shape, the voltage will look like this. The voltage will look like this. Pure sine wave. This is the voltage wave shape. Now, if we need to draw the current wave shape, then roughly I can draw the current like this. Let's say I want to draw the current only in the positive half cycle. The current, this red curve. Let me redraw it. The current will look like this. It will look like this. The current shape will look like this in positive half cycle. Now, this point is very important. I want to draw this current only in positive half cycle up to this point only. Let's call it beta. Let's call it beta point. Let's call this point as beta. Okay, I want to understand this current up to beta point. Okay, let's try to understand this. The first point which is important to me is this point. This point is very important for me. How to calculate this point? Now, this is the current wave shape. So I can say that if this is the current wave shape, the wave shape of the VRT will also be like this. Because we know that the VRT will be equal to R into IT. Voltage across the resistor will be equal to R into IT. It means whatever the shape this IT has, the same shape will appear for voltage across the resistor VRT. VRT will also have the same shape. Okay, so now you can see that if this is the current wave shape, then the wave shape for VRT will also be like this. Let's call it VRT. Let's call it VRT. This red line curve, call it VRT. And if you apply the KVL in this circuit, then you can say that VST minus VRT, VST minus this VRT, minus this VLT, is equal to 0. This is KVL equation. VST minus VRT minus VLT is equal to 0. This is my KVL equation. So from this KVL equation, you can say that VLT is equal to VST minus VRT, right? VST minus VRT. From this KVL equation, you can say that VLT, voltage across inductor, will be the difference of supply voltage and the voltage across the resistor. And we have drawn the supply voltage and the voltage across the resistor. What we need to do is we need to take the difference. If we take the difference of VST and VRT, we'll get the VLT. Now, let's see the difference. Let's see the difference. We can see that up to this point, if you look at this point, up to this point, this is my VST and this is VRT. So the difference VLT is this. This is my VLT. You can see that this is my VLT. This is my VLT. And you can see that since VST is greater than VRT, VLT is positive. During this interval, from this point to this point, VLT is positive. That's why the current is rising. That's why the current is rising. You can see that. Because VLT is positive means L di by dt. L di by dt. L di by dt is VLT. And if it is positive, it means the current will be rising. So the current is rising. You can see that. You can see that the current is rising. At this instant, what happens is, at this instant, VLT becomes 0. At this instant, VLT is 0. And I told you, if VLT is 0, current has the maxima or minima. Since it was rising previously, so it has maxima. Okay, it has maxima. So you can say that at this instant, whenever there is a crossing of VRT and VST, at that instant, we have VLT equal to 0. Because VRT and VST are equal. If VRT and VST are equal, at that instant, VLT will be 0. It means current has the maxima point. So at this instant, we have the maxima point. Now, after this point, what will happen? After this point, you can see that, up to this beta point, you can see that VRT is more than VST. If VRT is more than VST, then you can say that VLT is negative. And if VLT is negative, if VLT is negative, then you can say that the IT will fall. DIT by dt will be negative. If DIT by dt is negative, it means current is decreasing. So you can say that after this point, current will decrease. So VRT will also decrease. You can see that the current is decreasing and VRT is also decreasing. Okay. So after this point, up to this point, you can say that VLT is negative because VST is less than VRT. So VLT is negative. If VLT is negative, L di by dt is negative. It means di by dt is negative. Current will be falling. So you can see that the current is falling after this point, up to this point. Now, let me tell you one more point in inductor, which you should remember. Let's say I have some inductor. Okay. I have some inductor. And let's say I have applied some VST. I don't know the shape of VST. And there is a current IT. Let's say the wave shape of current IT is like this. Please be careful. This is important, guys. Let's say the wave shape of current is like this. Let's say the waveshape of current IT, current through the inductor is like this. So the current through the inductor is starting from 0 value and it reaches 0 again at some instant, let's say beta. It reaches again 0 at some angle beta. It means the same value is repeated here. So what you can say is, just by looking at these 2 points, you can say that between 0 and beta, the positive voltage across inductor, the area under positive, I mean, you can say that within this interval, 0 to beta, the positive voltage area across inductor will be equal to the negative voltage area. You can say like that. It is very important point. If the current is repeating the same value after some time, let's say, at this 0 and this beta, if the current is repeating in inductor, if the current is repeating the same value, let's say it started from 0 and it again reaches to 0, then you can say that the positive area of VLT will be equal to the negative area of VLT up to this point. And you can see that here the current starts from 0 value and again it reaches to 0 value. So you can say that whatever the positive area is, the same will be the negative area, because the current value is repeating itself. The current value is repeating itself. Repeating means average value should be 0. Average value 0 means the positive area must be equal to the negative area. I hope you understood this point. It's very important point. Let me tell you this point in a different way. Let's say I have an inductor circuit, or maybe there is some circuit in which we have some inductor connected. Like let's say the circuit is like this. RL circuit is there. Okay. If the circuit contains R and L, okay, and here is some circuit is there, and in that circuit RL is there is one branch which has R and L. Okay. Now in this branch the current is IT, and the wave shape of IT is given like this. Let's say the IT at t equal to 0 start from this value. Let's say this is the current wave shape. Let's say this is the current wave shape, IT. And there are 2-3 points. This point is A. And this point is B. Okay? This point is B. Wait a minute. Let me write it properly. Let's say the current wave shape is like this. Wait a minute. Let me write the current wave shape. The current wave shape is like this. Okay, this is the current wave shape, guys. Okay, obviously it's not periodic. You can see that it's not periodic. It's a different, I mean, it's a random wave. But let me tell you one interesting point. Let's say this is the current wave shape, and there are some points A. This point is B. Yes, Shivam, please wait. I'll come to your question. This point is C. This point is D. Okay, so there are so many points A, B, C, D. Now if you look at these points carefully, I can say that, let's say the angle here is, let's say this axis is omega t, here the angle is 0, and here the angle is alpha 1, let's say, or alpha naught. Here the angle is, let's say, alpha 1, here the angle is alpha 2. Okay, now what I can conclude is, because at t equal to 0, the current starts from this value, and the same current will appear at alpha naught. So you can say that whatever the voltage VLT, if you try to calculate the area of VLT from 0 to alpha naught, that must be 0. You can say like that, because this value is repeating again at this point. If the current in the inductor is repeating, I mean, so just look at the interval in which, I mean, it will come again to the same value. Just look at that interval. If you calculate the area of VLT in that interval, that must be 0. Just remember this point. It is very important point, guys. Similarly, you can say that from alpha naught to alpha 1, again 0, because it is repeating the same value. Okay, it is repeating the same value. Let's say this is alpha naught, this is alpha 1, this is beta naught, this is beta naught, this is beta 1. Okay, and this point, let's say Okay, okay. So this is alpha node, this is beta node. Let me change the color. This is 0, this is alpha node. This point is beta node. Okay. This point is beta 1. This point is alpha 1. This point is alpha 2. And this point is beta 2. Okay. This point is beta 2. Now, which statement is true? Which statement is true? Which statement is true? MSQ question is there. Which statement is are true? Which statement is are true? Tell me, guys. First statement is this. Now the second statement. The second statement is integration VLT dt from beta node to beta 1 is 0. The third statement, integration VLT dt from alpha node to beta 1, from alpha node to beta 1 is greater than 0. Alpha node to beta 1 is greater than 0. Number 4, integration from alpha 1 to maybe beta 1 to alpha 2. Beta 1 to alpha 2 VLT dt is positive. Which option is correct? Tell me, guys, which option is correct? Which option is correct? Tell me, guys. So this is MSQ question. You can take the screenshot of this question and you can share it with your friends. So the current wave shape is given to you. Current is aperiodic. It's not repeating. It's not repeating. But there are some points which are shown. Now I want to ask you, which statement is true? First statement is this: 0 to alpha node, and then beta node to beta 1, and then alpha node to beta 1, and then beta 1 to alpha 2. Which statement is correct? Tell me, guys. Which options are correct? Do it fast. Tell me the answer. Let me see how many of you are able to solve it. Which statement is true? Ashish is saying all. Okay, Shivam 1 to 3. Tell me, everyone, if you know the behavior of inductor, you can easily solve it. There is nothing to worry. Okay, it's very simple. Only statement 4, Lochan Bhatt. It's MSQ question. More than one options are correct. Tell me. Okay, let's see. From 0 to alpha node, if you look at this, at t equal to 0, let me change the color first. At t equal to 0, you can say that the current is A. Current is this. And the same current is repeating at alpha node. I told you, if the same value came, let's say at 0, the current was here. At alpha node, the same value appear. Then the voltage, the area of VLT will always be 0. That's true for sure. That's true for sure. That is surely true. Okay? That's true for sure. Now, let's come to the next point. Similarly, you can see from beta node to beta 1. This is beta node and this is beta 1. You can say that the current is repeating again, same value. At this instant, the current was 0. At this instant, the current is again 0. It's repeating. If it is repeating, then you need to calculate the area of VLT from this beta node to beta 1. That will again be 0. That is again true. That is again true. Statement number 2 is also true. Now, let's come to statement number 3. In statement number 3, you can see that at alpha node, the current is positive. And at beta 1, the current is 0. It means the current has decreased. The current has decreased. At alpha node, the current is positive. And beta 1, the current is 0. At alpha node, the current is positive. And at beta 1, the current is 0. It means current has decreased. If current has decreased to some value, if current has decreased to some extent, then if you need to calculate the area from this point to this point, if you need to calculate the area of the voltage across inductor, it has to be negative. It cannot be positive. Okay, it has to be negative because current is decreasing. Current has decreased from this point to this point. Current has decreased, so it has to be negative. This is not true. This is not true. Is it fine, guys? Is it fine? Now let's come to the next point. Point number 4. Tell me, guys, from beta 1 to alpha 2. From beta 1, this point beta 1 to alpha 2. This is beta 1, this is alpha 2. This point is alpha 2. The current here is 0 and the current here is positive. Now tell me, current has increased. If current has increased to some value, it means voltage across inductor has some positive area. Then only the current can be positive. Current has increased to some value. If the voltage across inductor is positive, then the current will be some higher value. Current will reach to some higher value. Okay. So answer 4 is also correct. So 1 to 4 is correct. 1 to 4 is correct. Is it fine, guys? Is it fine? Now many of you will think, sir, how it happens? How it happens? Let me tell you. Let me tell you how this concept is, from where this concept came. This is again very important question, guys. Please note it down, because students don't know the basic things. Students don't know the basic thing. They are studying so many difficult things, and look at this basic question. This is MSQ question, and it's a very good question. Let me tell you how this happens. How this happened. Let's say I have an inductor. Let's say I have an inductor. Okay. I have an inductor, and let's say I have the voltage VST. Let me tell you, guys, and the VST shape is like this. VST shape is like this. Wait a minute. Okay. Actually, there are two situations in which, in first case, VST is like this. Let's say this is my VST. And then, in the next cycle, the VST is like this. Okay. 0, 1, 2, 3, 4. Let's say this is my VST. Now, what I need to do is, I need to plot the current wave shape. Let's say this is 10, this is minus 10, and this is minus 5. Okay. This is the VST wave shape. This is t in time, t in seconds. This is the wave shape for VST, and the inductor value is, let's say, 2 Henry. I need to plot the wave shape for current IT. Sir, alpha 0 to beta 0 not equal to 0, and okay. Lochan, but I thought it necessary that the current should be periodic for average voltage to be 0. No, it's not average value. It's not an average value, it's area. Average value is area under one period. I have not taken the one period. It's not average value. We call it instantaneous average. There is a difference in instantaneous average and average. Don't be confused. This is not average value. This is area up to some point. Let's say this is the wave shape. Let me teach you first. I'll come to this question again. I'll teach you first this concept. Okay. First try to understand this concept, and then again I'll come back to the question, and I'll try to explain you. Let's say this is my VST, and this is the inductor L, and the initial current is given as 0. I need to plot the current wave shape, and then I need to find some important points. Okay. First, let's try to plot the current wave shape, and then we will try to find the important points, and then we will come back to the question, and then I'll take your question. Okay. Shivam, I'll take your question. Please wait. Okay. Just let me explain this, and then I'll come back to your question. Okay. So now let's assume that the initial current is 0, and this is the voltage wave which is provided to you. I need to plot the current wave shape. I know that the current equation is equal to I0 plus 1 by L integration 0 to t VLT dt. If it starts from 0, then this should be the current equation. Now I need to plot the current equation. So let me change the color. So first of all, let's plot the current equation. Now from 0 to 1, can you calculate the current equation? What should be the current? This equation will be used for calculating the current. You can see that the initial current is 0 plus 1 by L. L is 2 Henry. From 0 to t, what is VLT? VLT is 10. But this 10 is valid only between 0 and 1. So you can say that the t should be 0 and 1. Okay. You can't put t more than 1 second, because this 10 volt is valid only in 0 and 1 second. So you can calculate this and you'll get 5t. You'll 5t. Okay. So you can say that the current will rise. And the equation will be 5t. At t equal to 1 second, you can say the current will rise up to 5 ampere. Is it fine? Current will rise up to 5 ampere. Now, from this point to 2 point, let's calculate the current from 1 to 2. Now the initial time is 1, not 0. Now the initial time is 1 second, not the 0 second. So the current equation will be IT will be equal to I1 plus 1 by L from 1 to T VLT dt. Now this is the equation that I need to use. Now I1, what is the initial current at t equal to 1? At t equal to 1, initial current is 5 ampere. So 5 plus 1 by 2 integration 1 to t. What is VLT? VLT is minus 10. Minus 10 dt. So it will be 5 minus 5 t minus 1. That will be minus 5t plus 10. This is the current equation, guys. Minus 5t plus 10. So at t equal to 1, but remember the t, you can put the value of t between 1 and 2 only. T is valid between 1 and 2. Why 1 and 2? Because we have put VLT equal to minus 10 and minus 10 is valid only between 1 and 2. So that's why you can put 1 and 2. So if I put 1 and 2, at t equal to 1, it will be 5. At t equal to 2, it will become 0. So the current will return to 0. Current will return to 0. Okay. Now, let's come to the next 2 to 3. Let's see 2 to 3. What will be the current from 2 to 3? Now from 2 to 3, again, the equation will be IT will be equal to I2 plus 1 by L 2 to T VLT. What is VLT now? VLT is 10. 10 dt. And what is I2? I2 is 0. I2 is 0. And VLT is 10. So you should remember that this T should be valid between 2 and 3. T, you can put the value of T between 2 and 3 because this 10 volt is between 2 seconds and 3 seconds. No? That's why the T can be valid between 2 and 3. Now if you calculate it, you will get 5 into T minus 2. It will be 5 into T minus 2. This is the equation now, current equation. At T equal to 2, it is 0. At T equal to 3, it will become again 5. It will become 5. Perfect. Now, 3 to 4. Let's see 3 to 4. Now, you can check it yourself. From 3 to 4, it will be 2.5. So, at this point, it will be 2.5. At 4 seconds, it will be 2.5. You can check it. Okay. And then it will remain constant. And then it will remain constant. Okay. This will be the equation for the current. This will be the equation for the current. I don't think that I should plot this. I should calculate this. It's your part. You can do it yourself. Okay. This will be 2.5. Now let's see the important points. See the important points. And these important points are very important, guys. That's why I call them important. Now look. At this time, the current starts from 0. It again comes to 0 value at 2 seconds. It means up within this interval, the area of VLT should be 0. Check it. 0 to 2, you can say that the positive area is equal to the negative area. So it's true. You can say that. Between 0 and 2, since the current repeats itself, since the current repeats itself, so you can say that between 0 and 2, area has to be 0. You can see that the area is 0. Voltage across inductor has 0 area between 0 and 2. Now you can see that at t equal to 1 and at t equal to 3, the current is repeating again. 1 and 3, the current is repeating again. So now you can see that within this interval, if you calculate the VLT, area of VLT, that will again 0. Now 1 and 3, if you look at area between 1 and 3, the negative area is equal to the positive area. You can see that. Again, current is repeating. Now, let me tell you guys. If you look at from 2 to 4, if you look at the area from 2 to 4, think carefully. At t equal to 2, the current is 0, but at t equal to 4, the current is positive. Current is positive. What it means? It means that the area of the VLT will not be 0, it will be positive because the current has increased to some value. From 2 to 4, the current has increased to some value. From 0, it has increased to 2.5. It is not coming to 0 value again. From 0, it has increased to 2.5. So you can say that between 2 and 4, if you try to calculate the area of VLT, it will be positive because current has increased to some value. Now you can check that from 2 to 4. If you try to calculate the area, you can see that this is higher area. This is 10 and this is minus 5. So the total area is positive. Okay. I hope you understood it. Okay. Now let me ask you one more point. Think carefully. This is important. Let me ask you one more point. Let me change the color. I think this color, okay, red color is nice. Okay, let's say from 3 to 5. Tell me about 3 to 5. Don't look at this wave. Just by looking at the current point. 3 to 5. What should be the area? What should be the VLT? Whether it is positive or negative? Tell me, guys. From 3 to 4. Tell me whether it is positive, negative or 0. Tell me, guys. Don't look at the wave shape. Just by looking at the current. Can you tell me between 3 and 4? At 3, the current is higher value. At 4, the current has lower value. It's not repeating. It's not coming to the same value. Fine. It has decreased. From 3 to 4, you can say that the current has decreased. If the current has decreased, it means the area will be negative. Between 3 and 4, the area will be negative. VLT area is negative. Okay. The same thing I asked in this question. I hope you understood it. Tell me, guys. Tell me, everyone. Is it fine? Now, you can ask me your doubt now. You can ask me. Is there any doubt? Shivam. Tell me, Lochan, but no, it's not necessary. Look, this current is not periodic. This voltage is not periodic. And I am discussing on aperiodic wave shape. Okay, even if the wave is aperiodic, just understand the important points, understand the points, what these points are telling to you. Okay, and using those points, you can make any type of question. I can make any question. I mean, based on this question, I can frame any type of question. Let me ask you one more point. At 4, the current is 2.5. And at 2.5, the current value is again 2.5. Now, tell me about the area. VLT dt from 2.5 to 4. Tell me, guys, what should be this area? Is it 0? Tell me, guys, from 2.5 to 4, what is the VLT dt? Tell me about VLT dt. Tell me, guys, what is this value? What is this area from 2.5 to 4? From 2.5 to 4, what is this area? VLT dt. It's 0. Why it is 0? Because it's repeating. The current value is repeating itself. Okay. That's why it will become 0. Okay. I hope you understood it. Is it fine? Now, let me tell you one more point. Let's say from 0.5, from 0.5 to 4, tell me the area. From 0.5 to 4, VLT dt. Tell me, guys, what is this? Is it 0 or positive or negative? Tell me, everyone. From 0.5 to 4, tell me the area. Is it positive, negative or 0? Tell me, everyone. It's again 0. Why 0? Because at 0.5 it's 2.5 and again at 4 it's 2.5. It means it's repeating. So if you calculate the total area of VLT from this point to this point, it will be 0, and you can see it from here. At 0.5, from this point to this point, if you try to calculate the total area, that area will be 0. You can see from the wave shape, you can verify it. Okay, so I think it's very easy concept and very important. So this was the question which was based on the same concept, and I'm pretty sure that 99% student will do the mistake in this question. Okay, so that's all for today's session, guys. The same concept is applicable for capacitor, but in case of capacitor, current and voltage will be interchanged. Okay, wherever the current was there in capacitor, it will become voltage, and wherever the voltage is there, it will become current. Okay, so in capacitor, same concept is applicable. Okay, so you have to be careful while understanding the capacitor and inductor, and don't forget to write the transient equation. The transient equation tells us many things. Okay, The transient equation is very important. This equation tells us that the current is repeating, the current started from 0 here and it will come again 0 at this point. It means current is repeating at this beta point. It means whatever this positive area is, the same has to be the negative area, so that the total area becomes 0. Okay, so it's very important. Sir, why current is maximum at pi by 2? No, it's not maximum at pi by 2. No. Who told you that current is maximum at pi by 2? Current will be maximum whenever this VLT is 0. And when with this VLT will 0, whenever this VST and VRT are equal. Whenever the VST and VRT, so this is the waveshave for VRT and this is the waveshave for VST, blue color. Blue color is for VST, red color is for VRT. Whenever at the point wherever these two waves are intersecting, at that point VST and VRT are equal, so VLT becomes 0. If VLT is 0, I told you, whenever the VLT is 0, whenever the voltage across inductor is 0, current has the maxima point. Okay, so that's why the current is maxima at this point. And this is not pi by 2. Okay, this is not pi by 2. Who told you that this is pi by 2? Okay, so be careful, guys. I hope you enjoyed this session. Tell me about today's session. This is your homework. You need to write the current equation. The switch is closed at t equal to 0. Write the current equation. Write the current equation. This is your homework. Okay, do it yourself. Okay, guys. So tell me about the session. How was the session? Have you understood some concept? So this was very crisp and very interesting session. Anyway, I hope you enjoyed. Capacitor में भी बोल सकते हैं ना, voltage periodic है तो current periodic होगा. Yes, but not only in ideal capacitor case. If capacitor is coming with resistor, then you can say that. If capacitor is coming with resistor, then you can say that. If there is only single capacitor is there, then you can say that. Then you have to make the statement like this only, which I have told you in case of ideal inductor. Okay, same way you can make the statement. Okay, so it's a, you can say capacitor inductor, you just interchange the voltage and current, everything is same. Wherever you used the voltage in inductor, in case of capacitor you replace the voltage with current, everything will same. Okay, so I hope you understood it. Anyway, that's all for today's session, guys. I hope you enjoyed. So it's time to subscribe the channel. So please subscribe our YouTube channel and like the session if you haven't liked it. So please like it and press the bell icon so that notification you get the notification whenever the video is live, or whenever the video is there, then you'll get the you'll be notified. There is a mobile app which you can install, and on this mobile app also you will get some sessions, free sessions. There is one series is going on, which is rank booster series. So you can join that series. It's free of cost. In that series we solve maximum questions. So I hope you will be benefited from that series also. So please join our mobile app, and from mobile app you can attend the classes. So I hope you enjoyed. Thank you for showing interest in this class. See you tomorrow with some new concepts. Thank you and take care. Bye.